everyone, welcome back to the next part of the series. Today we're going to start making the player, we're going to work on the camera, and we're going to create a script that will allow us to move the character around the screen. First, we're going to create an empty object. We're going to call it player. Let's zero out the position of it. We're going to have this as an empty object that's going to contain our scripts and physics and colliders. And we're going to create a second object that's going to be the child of the player that's going to contain the sprite. We're going to have the sprite and the player separated. The animator can conflict with the player actions, and we want to separate them so that the animator can perform its movements. Meanwhile, the player will move in the direction you desire. Before we add the image to the player, first we're going to split up the sprite sheet. So go into the sprites folder, follow the sprite sheet, and then you'll find the sprite sheet characters. Just like in the previous video, we will have to separate the sprite sheet into multiple images. So first we're going to change it from single to multiple. We're going to change the pixel count to be 24 because that's the size of our characters. And we're going to change the filter mode from bilinear to point, so the pixel is preserved when scaled up. Apply the changes and open the sprite editor. Let's slot it in here. We're going to slice it, change it to grid by cell, and set it to be 24 by 24. This will cut them out individually. Make sure to click the apply. The asterisk in the sprite editor tells you that the progress hasn't been saved. And now you have multiple character sprites that we can use for the game. We will use these ones. Choose whichever one you like. I'm going to stick with the green one. Grab whichever character you like and drag it underneath the player. As you can see, there's our player. What we're going to do is we're going to rename this to be called Sprite. Now that we have our player, let's just take a look at the camera and see how it's viewed. So when we click on the camera, you will see the preview of the gameplay scene. We can also just click here and see the gameplay scene. Our camera will be positioned at 0, 0, minus 10. The reason why the Z is negative 10 is so that the camera is in front of the sprites. Now, looking at the camera component, we can go over a couple things. Background is the basic color that will be taken on by the game. So right now it's a blue that's transparent. With the full alpha it's blue. We can turn off the camera and you'll see that the background of the game is blue at the moment. Next, a very important setting for the camera is the projection style. There are two types of projections, orthographic and perspective. Orthographic means that every object is equal distant from each other. So it doesn't matter if the camera is minus 100 or minus 10 or minus 1, all the images in the screen will look exactly the same. It's perfect for the use of 2D games. On the other hand, the perspective takes account in how close an object is to the camera. So the further away it is, the smaller the images get and less rendered and less detailed it becomes. We will stick to the orthographic. Next, we have the size. This will allow you to zoom in and zoom out your camera. For our game, let's stick to an 8. Clipping planes, we don't have to worry too much about. Clipping planes determine how close something has to be for it to clip into the camera. It's mostly used for when 3D objects start interacting with the camera and the camera goes into them. Viewport is a really cool tool you can use. With it, you can have multiple cameras and they can take up different sides of the screen. So for instance, if I change the width to be 0.25 by 0.25, the game takes up this much space and you can create multiple cameras with multiple images. If I do 0.5 by 0.5, we take up half of the screen, and you could create a secondary camera that takes up a second half of the screen by changing the offset by 0.5, and you could have two players. So let me do that right now. And there you go. We're not going to utilize this in this game, but it's a useful thing to know for future references. Next, we're going to go back to our player and add a collider and a rigid body so that they can interact physically with the world. Make sure it's a 2D box collider. Let's zoom in on our player in the scene. We can click this button to view the collider. Let's turn off the background. There we go. This is a perfectly good collider for the game we are creating. Next, let's create a rigid body. We're going to leave most of this as is, with the exception of the Z rotation. We want to prevent any rotation around the Z-axis, so our character won't sway and tilt if they interact with something. if Z rotation was left on, anytime our character would have collided with anything, they would have tilted and tipped over, and that's not conducive to the project we're making, but it can be a really fun tool in a different type of project. Let's turn on background. Now, we have all of that set up, but there is nothing allowing us to move the player. To do that, we will create our own custom script. Go into your assets folder, go into the scripts folder, and we're gonna create a C# script. We're gonna call it player movement. Now, what we're gonna do is we're gonna double click on it, and it's gonna open up Visual Studio, in which we will be able to program. Welcome to Visual Studio. This is where we're gonna program our game from. First, let's break down what we're looking at. On the top, we have things that say using. Those are other scripts that we are calling to use their functionality. Next, let's start with the class section. Don't worry about the public yet. We're going to talk about that in a minute. First, let's talk about the class. Class is basically what the script is. Class defines all its attributes and abilities to perform tasks. Next, it's followed by the name of the class or the name of the file. The name of the file and the class have to match, otherwise you will get an error. And then you have this colon that says mono behavior. This is called an extension. This tells us that we are copying behaviors from this mono behavior class. And this allows us to slot our script into the Unity inspector. Next, let's talk about these two. Two will always be included in an empty file that you create. The start method will always perform a task whenever the game starts. Next, you have an update method. This will continuously perform whatever action you put into it. We will learn all of this and become more familiar as we go along. But for now, just copy the steps I am taking. Before we get to moving our character, let's talk about some basics of programming. Let's quickly discuss the idea of the body of class and method/function. These brackets at the very start and end signify that anything inside them belongs to this class. Anything outside doesn't belong to it. It's likewise the same with the start and update method. They have their own brackets and they define what's inside them and what's outside. Let's discuss the idea of a variable. A variable is any sort of information. It can come in different types. We call them data types. Some ideas are integers, for example. So for example, here I am defining an integer that's going to be called number. Then the name can be anything as long as it's not a pre-taken name by the C# or Unity engine. And then I can say equals 0. So right here I defined a variable that's an integer data type and it has the value of 0. What we can do with this is we could print it out. So if we use a class called debug and we call a method called log, we can do this, and then when we run the program, 0 will print out in our console. Just like in Unity, anything you do in here isn't automatically saved. If it has a little asterisk at the top of the name, you have to click the save button and then we'll be able to perform the actions in the game. Let's go back to Unity and see it in action. Each time you save, Unity will have to reload your scripts, so you have to give it a minute to do that. So we're gonna go to our player, not the sprite, and we're gonna add our new script. Let's add it to the top. Right here you can see that the script is part of the game. Now if we check our console, or you can even see it down here, our script printed out a 0 for us. Next, we're going to do something similar in our update method. However, we're first going to discuss different types of variables. Right here, I've defined our variable inside the start function. That means if I try to do debug.log number, I will get an error. Error is always identified by these red underlines. That's because this function doesn't know that this number exists. The way I can fix that is I can create a global variable. A global variable can be used in any method or function. I'm going to create a new variable called int, and I'm going to call it number2 equals 0. You may have noticed that I did a capital 2. That is called camel case. Every new word should be capitalized. It makes it easier for the programmer to read and anyone else that may ever read your code in the future. Let's take this number 2, copy it, and paste it on top of R2, and you see the error has gone away. Now to test out our update method, what we're gonna do is we're gonna manipulate our number 2, and we're gonna make it equal to number 2 plus 1. This will increase it forever, so when the game is running, you will notice an ever-increasing number being printed out by the game console. Let's save, and let's go back to our Unity. Let's click play. As you can see, the number is increasing very fast. Now let's use some of these concepts to make our game run. First, let's clear out our script. And we're going to create a new global variable. This global variable is going to be called rigid body 2D. We're going to be using the rigid body to move our player. Let's call it rigid body 2D. And let's put a semicolon at the end. First thing we're going to do is connect this rigid body to the actual rigid body that's part of our object in game. So what we're going to do is rigid body, and we're going to use the get component method with the defined type of rigid body. Let's save and go back to Unity to talk about what that means. So our player movement and our rigid body are basically separate entities, but with the use of this line, what we're saying is, since this script exists in the same inspector as the rigid body, we're gonna reference it, or we're gonna have some kind of like connection to it, so we can manipulate these values. Next, we are going to collect the information from our player. There's many ways to do this. One, you could do input that get button, get access, get key. For example, right here, Visual Studio has filled in a random one for us. This is saying if the player is touching the key left shift, we could do something. What we're gonna be doing is we're gonna be collecting the information from the Unity's input manager. We can do it by going to Edit, Project Settings, Input Manager. And then you may have to unfold this bit with the axis. You can see all the pre-made inputs that are already associated for us. We're going to be using the horizontal and vertical inputs. So right here you can see that the left, right, A and D buttons have been connected to moving left and right. And likewise up, down, up, S and W have been connected to the vertical motion. And it has multiple other inputs that you can automatically link to your game. Let's start by moving our player left and right. Let's get rid of this, and we're going to create a new data type called float. The difference between a float and an integer is that integers can only be whole numbers, so 1, 2, 3, 4. Floats, on the other hand, can have decimals. So they can be 0.5, they can be 1.5, they can be 3.50. So we're going to use that because it's a bit more accurate to our player. We don't want them to skip every one block. We want them to move in tiny increments that the player is holding the keys for. We're going to call it X movement. And we're going to use the input that get axis, parentheses, and we're going to type in the name of our input manager. So for this case, it's horizontal. Now what this does is basically says if the player is not touching the keys, X movement equals 0. If the player is holding down A or the left key, the movement is -1. If the player is holding D or the right key, the movement is 1. Next thing we gotta do is feed this information into our rigid body. So what we're gonna do is go rigid body, that velocity. So what I'm doing here is I'm accessing a public global variable from the rigid body. So we're going to assign a velocity to our rigid body. When we hover over the rigid body, we can see that the velocity is a vector2. What a vector2 is, it's basically a list of two objects. So for example, we can say it's vector2 new vector equals 0, 9, 9, and that's the vector it's going. What we're gonna do is we're gonna take our pressed button, and we're gonna use that to select our X velocity. So we're gonna create a new vector. We're gonna set X movement to be this, and then whatever the rigid body is doing at its time, we want to continue having that velocity in the Y direction. So we're gonna do rigid body, that velocity, that Y. This will keep whatever information was there when the player clicked down on the button. Let's save it and test it out in game. So we can now move our character left and right, but the character is fairly slow and the character doesn't turn in the direction we are moving. Let's rectify that. By going back to our script, we can create a new variable. We're going to call it a float, and we're going to call it X multiplier 4. Let's make this a public variable. Basically, a public variable, like velocity, is a variable that other scripts can interact with, but you can also edit them in the inspector. For now, let's take our X multiplier and let's multiply it by our movement. So in this situation, when the player clicks left or right, it will be multiplied by 4. Let's save it, go back to our Unity, and you can see that the 4 is now in our inspector. You can change this at any point in time, and whatever value you put in here will be the value that is there as the basis. So let's click play and test it. And now you can see our character is moving along much faster. Next, let's deal with the sprite not facing the correct direction. If we go to our sprite, we will see that it has this flip ability. If you click it, you will notice that the character flips the direction they're facing, and you can even flip them upside down. We are going to interact with this directly in our script to make it happen. Let's go back to the script. Like with the rigid body, let's try to get the reference to that object. So we're gonna get a sprite renderer. We're gonna call it sprite renderer. However, unlike the rigid body, the sprite is not directly connected to our object. The sprite renderer is a component in the child of the object that this script is connected to. So what we're gonna do is we're gonna do sprite render, and we're gonna go transform, and we're gonna get child. Basically what we're saying here is, look at the very first, in programming 0 is the first child that this object has, and get the component from it called sprite renderer. So let's look at it in here. Our player has its first child, it's called sprite, and that sprite contains a sprite renderer component, and we're gonna have a reference to it. Next, we're gonna introduce an if statement. If statements test if something is true or not. So for example, in this situation, we can say if X is bigger than 0, we will take our sprite renderer and we're gonna flip it, make it true. Otherwise, the sprite renderer that X will be false. So if the player is moving to the right or is not moving at all, the player will face right. And if the player is moving negative direction, the flip will be turned off. Let's save this and go back to our game. Alright, so as we can see, the player now changes the direction they're facing, and in the inspector you can see that we are actively changing that variable with the checkmark being turned on and off. This will conclude the first part of us putting together our player. Next, we're going to go into our player being able to jump and upgrading our camera so that it follows the player around while they're moving across the map.